Randy Cole is here to demonstrate. And let me just give you a quick brief thing on what he's talking about. The composite insulators for guy wires CSA standard C411.711 was released in 2011 to address industry concerns of guy strain insulators being used in electrical applications. This presentation will discuss this change and the importance of electrical utilities interpreting and complying with this standard. Thank you, Randy.
Is this, it's working, okay, great. Everybody can hear me fine? Okay, well, thank you for coming. Always wonder about being the first one in the program that you're gonna get an audience. So when I first came here, it was just John sitting there. It was gonna be very intimate. So a little larger group, which is great. Very informal session. I just wanted to talk a little bit about the subject of guy strains. And first, just a little bit of an intro for those of you that aren't familiar with K-Line. K-Line group of companies consists of several sister companies. K-Line Maintenance Construction, so if you're in the outdoor area, you see our large green vehicles out there. That's the construction side of our business. We have K-Line International, which does line construction, but on an international basis. K-Tech Electrical Services, they do testing, they do design, electrical testing, design work, and then of course K-Line Insulators. So we're a one-source solution provider for electric distribution and transmission. We're a privately held Canadian company, committed to quality and safety, and within the group we deliver the variety of competencies that you see there: engineering, design, procurement, construction, commissioning, T&D maintenance, then the manufacturing, which is the K-Line Insulator side. So I just wanted to give you just that little background and then move into the subject of guy strain insulators. So no, we're not going to talk about the old Johnny balls. You can see them all here, chained for protection, a very, very old picture, and I guess the idea was, you know, the guy strain insulators are used for public protection. Want to talk a little bit more about the modern technology where you're talking about guy strain insulators, and I'm sure everybody's familiar with guy strains. They're a composite type of fiberglass rod, resin impregnated fiberglass strands that make the core rod, and there's some type of protective covering. In some cases, it's a UV protective paint, and in other cases, some manufacturers, as K-Line, it has a silicone rubber coating sheath on it. So the scope of the CSA 411 7-11, is everybody pretty much familiar with the new polymer insulator standards in the CSA 411 group? There's a CSA 411 standard for line post insulators, one for dead end suspensions, and one for guy strains. You might be more familiar with the former standards, the CEA LWIWG, the CEA Lightweight Insulator Working Group standards. The CSA has taken over the standards from CEA. So this standard was developed in 2011, released in 2011. It was made up by several participating utilities as well, all of the insulator manufacturers. And the standard covers requirements for guy composite insulators used in guy wires on overhead distribution lines operating at nominal voltage up to and including 75 kV. And the guy insulators, the purpose of guy insulators, as you all know, is to insulate or isolate the guy wires for corrosion protection, higher insulation levels, clearances for maintenance, and normal operation and safety for public and workers. And in some cases, you're talking about joint use workers. So there's the guy strain insulator, obviously. We'll have a little pointer here. I can use that to point. The one that I'm going to talk about today, and where the CEA, the change in the standard from the former, the CSA standard, the change from the former CEA standard, is more to do with the clearance side of it, where utilities are using fiberglass guy strains as extension insulators. Here's a common practice within the utility segment when you're looking to give yourself some additional clearance. In this case, for a load interrupter switch, you want to be able to move the energized point away from the structure, so when the linemen do maintenance on that switch, they can come in there with the switch in the open position, they can lift the loops, and then on each side, up the pole, now they have a fairly large work area to get up there and do their maintenance on that switch gear. When you look at a closer shot of that application, you'll note the extension in there is a steel extension strap. So many, many years ago, the standard practice within the utility industry was to use metal extension straps as extensions. So in this case, it's fairly easy to know where your ground is. You're talking about line voltage out at the end of the insulator. you've got a ground, providing that the extension strap is grounded, that would be your ground potential. What's happening a lot now in some of the modern times is people are using guy strain insulators as extensions. And these guy strains generally do not meet the standards to be used as electrical insulators. So when you get this type of an application, now you have line voltage at the hot end, of course. Now you have ground at the pole, which means you have voltage distribution along that rod. So unless you're using a guy strain insulator that has that capability to perform as an insulator, it's really a misapplication. Another common one, and especially here around Toronto where we have a lot of, or Metro, the LDCs, not just around Toronto, but a lot of locations in Ontario where you have a lot of double circuit vertical construction. Oftentimes they'll use a guy strain insulator to float that circuit out there and provide some clearance for the application. So you'll be using a guy strain insulator in series with a dead end suspension insulator. So we've known this for some time at K-Line. All of our guy strains, and you can just pass that one around, all of our guy strain insulators have a silicone rubber coating. So you can see when you look at the profile. So we've had interest in this subject for many, many years. Here's what an insulator does. This is just a graphic representation of the profile. You've got line voltage at the hot end, and at the cold end you have ground. We've modeled it using a, what do you call that, Zeb? It's a voltage, it's a E-field analysis software, shows the voltage distribution on the insulator. The red end, of course, is the hot end. The blue end is the ground. The scale is 27 kV down to 0. So you'll see how graduated, how the insulation, the voltage distribution is along a standard insulator. When you use an extension, an insulator and an extension, whether you use a one-piece unit as depicted in the drawing, which is what we call our extension insulator, or many utilities will do an assembly where they're using a guy strain in series with a shedded suspension insulator, the profile will look very, very similar. You've got line voltage, of course, at the hot end, ground, which means you have voltage distribution on that rod. We've done the same E-field analysis on the extension insulator, done the modeling, and it shows the same phenomena. Line voltage, ground. So the change in the standard that CSA put forth in 2011 was to take that into consideration and try to take care of that misapplication where people are using these as an insulator, using guy strain insulators. The standard for guy strain insulators in the CSA, and I'm not sure if everybody's familiar with the tracking wheel, but if you look at the CSA standard, you'll see it. The standard is, with all of the parameters and the test parameters of the tracking wheel, standard for guy strain insulator must meet 330 hours on the tracking wheel. The tracking wheel is basically a torture test. It's an accelerated life test. It's a very, very severe test of the material that's under test. You apply a voltage, you hit it with a salt spray, many, many cycles in 330 hours. So that's equivalent to, I don't know, 30 years in service. A very, very severe test. So you'll notice the change that's in the standard now, and it says in cases where composite insulators the composite is used in series with a shedded suspension insulator, they're now saying that this insulator shall meet 1,000 hours on the tracking wheel. Okay, so that's a very severe test with the spray on. That's basically the same test that a line post insulator or a dead end suspension insulator and a line post insulator has to meet the CSA standards. So what they're saying is these units, when it says shall, as you know in the standards language, shall means must. So it's compulsory if you're going to meet the CSA standard that you use a guy strain insulator or a specialty device that will meet that 1,000 hours on the tracking wheel. There is a second standard. Well, there's the tracking wheel. If you're familiar with the tracking wheel, you'll see that written up in the standards. Basically, the insulator is energized, the thing rotates, salt spray, and you go for 1,000 hours on that tracking wheel. There's a second tracking wheel number 2, which seems to be the more common tracking wheel used these days. A lot of the test parameters are very similar. Instead of 1,000 hours, it's cycles, it's 10,000 cycles, but the same clause applies, highlighted in red, that takes care of that concern. So in cases where a guy composite insulator is used in series, this unit must meet the 30,000 cycles minimum duration with the tank full. And for those of you who have seen that particular graphic in the standard, you'll recognize it. If you've been to Connectrix, you'll see the dip tank test. This is the tracking wheel number 2. This is the one that Connectrix is using and where we do a lot of testing of our insulators. So we've always known at K-Line that when you're doing guying, when you're using insulators as extensions or extension link insulators, it's a whole different application than just standard guys. They're being used as insulating links, they're being used on energized conductors, they're being used as insulators, so they should meet the insulator standards. We have our standard guy strain insulators with rubber coated, and with the rubber coating it gives you some protection for proximity type applications. Those guy strains are not intended to be in contact with the conductors obviously, but at times it's very, very close proximity. Here's your standard guy strain Johnny rods to replace the Johnny balls. A lot of people are using those. So the CSA standard is 100 kilonewton or 22,500 pounds tensile or specified mechanical load. Comes with a variety of different end fittings. You're all pretty much familiar with those. What's new for us, I guess, is the extension insulator. It's not new, but we've had them around for a long time, but more people are starting to use them now because of this change in the CSA standard. So the idea is an extra clearance option for voltages 15 through 69. You've got your standard lengths, 30 to 88. We can make them really whatever you need if you need some special lengths. You got a silicone rubber insulator, coated rod, and corrosion resistant aluminum fittings. I'm going fast because I have 4 minutes and 21 seconds, so I'm talking a little too fast here. But anyways, the idea here, as you can see, is very straightforward. You move that dead end point away from the structure. With the switch in the open position, it's very simple for the lineman to lift the loops, put it on the parking stand, do that on all 6 conductors, or 6 sides, jumpers, and now you've got a nice area up there for the guys to get up and do the switch maintenance. So there's the extension insulator. It consists of a sleeved rod, silicone rubber coating, and insulation class for the purpose, for the voltage that we're installing it on. These are just some application shots. The linemen, they do the dead ending the very same as they would normally. The linemen generally like the extension insulators. You know, they stand up in the bucket. You know, they're nice and easy to use. You don't have a lot of cotter keys or cotter pins to work with. Doing the dead ending through the same procedure. There's the bottom circuit done. The intent here is to put a switch on this double circuit pole, load interrupter switch. So there's the dead ending done on each side, completed, and there it is with the switch in position. Typical sort of applications, whether it's a load interrupter switch, you'll see oftentimes now if you're doing a single phase, or in this case it's a 3-phase tap off like to an adjacent circuit, and you can use, in place of that metal extension strap, there is now a purpose specialty product that will do it. We have some customers that prefer the extension insulator. Just pass that around. That's a 15 kV unit. It's very, very lightweight. The 46 is a little bit larger. So we have a lot of customers that like using that. Some clients still prefer, you know, they have certain insulators on standards. They want to use an extension link. So we have an extension link insulator that allows you to do that purpose. Use this insulator in series with your standard shedded suspension, and you'll have an assembly that will comply with the CSA standard from the electrical point of view. This gets the same test, or this is subjected to the same test as the line post insulators and the dead end suspension. So I think that's, I got 2 minutes left. Any questions? Anybody have any questions about the CSA standard or the products themselves? I know it's fairly quick. We're at booth 912, so we welcome you to come over to our booth, and we have, you know, this presentation that we can talk about a little bit more in depth if you have questions, and we also have a lot of other products on display there, and a chocolate bar. That's why we're here. Okay, well, if there's no questions, thank you very much for your attention.